uh, when we were trying to work around this expression, we wanted to find the values of a and b. B we found out to be 0, and then we found an expression for k and for energy also, but we still haven't found out a, right? So only if you find a, this expression is going to be complete, because your expression has to be in terms of x and well defined variables. It cannot be an arbitrary variable a. L is also a variable, but L is well defined. It is the length or the width of the potential well, but A is just some arbitrary constant, so you cannot leave it as such. So you need to find an expression for A. Once you do that, your derivation is complete. So how do we do that? Now, so we used our two boundary conditions. Probability of finding the particle at 0 is 0, at L is 0. But there is also a third condition, right? Between 0 and L is where my particle exists. So probability of finding the particle between 0 and L is going to be 1. And this is also the normalization condition. So integration, if you remember the normalization condition from the previous lecture, it says integration from minus infinity to infinity modulus of psi squared dx equals 1, assuming the particle exists somewhere in the universe. And here, because we know for sure that the particle exists only between 0 and L, we can replace minus infinity and infinity with 0 and L respectively. And it does not make any change, or it is not a violation of the condition in any sense, because we know for sure that the particle exists only between 0 and L. So the probability of finding the particle somewhere between 0 and L is 1. So we have this expression, integration from 0 to L psi squared dx equals 1. So we substitute psi squared with the expression we had, a sin n pi x by L squared. So integration from 0 to L, a squared sin squared kx dx, which is a squared sin squared n pi x by L dx, which is equal to 1. So now you take the a squared out, and then you have integral of sin squared n pi x by L dx, and this is a mathematical identity. Sin squared theta is half of 1 minus cos 2 theta. So 1 by 2, 1 minus cos 2 n pi x by L dx. So you take the 1 by 2 also out, it is integral of 1 minus cos 2 n pi x by L dx. So when you do the integration, this is what you will get, a squared by 2 x minus L by 2 n pi sin 2 n pi x upon L. And when you apply the limits from L to 0 and equate it to 1, finally the expression you get for A will be root over 2 by L.